Alright, welcome to lesson 5 on trapezoids. Sorry I'm so late at getting this out today, but I've had so many technical difficulties that it's taken me a long time to get this out. Anyway, lesson 5, trapezoids. We learned about trapezoids in the first lesson of this chapter. An isosceles, a trapezoid, is a quadrilateral with exactly one pair of parallel sides. Today we're going to talk about an isosceles trapezoid, which is a specific type of trapezoid. It's like an isosceles triangle. The same idea. The legs are equal. So there's some special properties for isosceles trapezoids that we're going to talk about today. We're going to talk about two of them. One is an isosceles trapezoid the base angles of an isosceles trapezoid are equal. And the other one is that the diagonals of an isosceles trapezoid are equal. We're going to do the first one. We're going to do a formal proof in proving it. So we have this is our isosceles trapezoid down here. They tell us that our bases are AB and BC. That's important because in a trapezoid the bases are parallel. And we want to prove that angle A is equal to angle B. I'm going to talk it through first, and then we're going to do the formal proof. So the first thing we're going to do is we're going to draw a line through C parallel to AB. Like that, and we're going to label that point E. You just have to imagine it parallel to this one. The next thing that we can do is say that since it's a parallelogram, we know that this side is going to be equal to this side. And since we know it's an isosceles triangle, we know that this side is equal to this side. Then we would use substitution to say that this is equal to this, because this is equal to this, and this is equal to this, therefore this is equal to this. So what we have here is an isosceles triangle, so we know that this angle is equal to this angle. Since these two lines are parallel, we know that the corresponding angles are equal. So this is equal to this, and this is equal to this. So we know this is equal to this, and we have our base angles are equal. So I'll quickly try to go through a proof just so you can see how you would write this up. Hopefully I can do this easily. And then we'll just talk through the proof to Theorem 45. It's actually on another video because I had trouble with this one. So, first thing we're going to do is we're going to draw our line. Sometimes in proofs you just have to draw a line. So we're going to draw through C. We're going to draw CE. And we're going to do it in such a way that it's parallel to AC. The reason that we can do this is because through a point not on a line, there is one line parallel to the line. You can draw a line parallel because through a point not on the line there's one parallel. Next thing we can say is that AECD is a parallelogram. The reason that we can say that is it has two pairs of parallel lines. So a parallelogram has two pairs of parallel lines. And we showed that because we drew one and it came with one. The next thing is we can say DA is equal to CE. And the reason we can say that is It was what they told us. It was an isosceles trapezoid. So DA, see if I can get up there. DA right here is equal to CB because it's an isosceles trapezoid. You know that the sides are equal. So you would say legs. Whoops. Actually, that's not what it is. DACE. DACE, not DACB. We know this is equal to this because the opposite sides of a parallelogram are equal. The opposite sides of a parallelogram are equal. Then we can say DA is equal to CB. And we know that because legs of an isosceles trap are equal. Now we can do CE, looking up at the drawing, is equal to CB. CE is equal to CB. CE, CB. And that is all by substitution. We went over that in the beginning. Substitution. We have this one is equal to this one. This one is equal to this one. Therefore, this one is equal to this one. And what we did was we made an isosceles triangle. So, because it's an isosceles triangle, in step 8, we can say angle CEB is equal to angle B. And the reason for that is angles opposite equal sides in an isosceles triangle are equal. And our final, almost our final step, I have to make a new text box over here. I can't fit it over there. So step 9, we can say angle CEB is equal to angle A. And the reason we can say that is these are parallel lines, and this is our transversal. So corresponding angles are equal. So this would just be corresponding angles are equal. And then finally, for step 10, hold on one second, we can say that angle A is equal to angle B. And the reason for that is substitution. Because we have this one equals this one, and this one equals this one, therefore angle A equals angle B, and we just proved that the base angle of an isosceles trapezoid are equal. You have to watch the other video for theorem 45. It's only like 2 minutes. I just had to, I had so many problems. So you have to watch that one, and then I'm also going to do one for homework problem. So that ends the proof of theorem 44.